Good morning, all of you. So we have to, okay, this one. Today we'll discuss about the problems related to Biot Savart law and its applications. Already yesterday we have started few. So today let me explore the other device, other current carrying instrument like solenoid, toroid. These are instruments are there due to which we are supposed to determine the magnetic field. So from previous class, what we learned based on that few numericals, what we discuss now. So we have to. There's a wire. You can see that one. There's a structure. A current I is flowing in this direction, and at point P we are supposed to calculate the magnetic field due to this current carrying structure. Look at these ends, they tend to infinity. You have to find out magnetic field at point P, that one. So what is the formula for according to Biot Savart law? Mu naught I 4 pi d sine alpha sine beta. Look at this sine alpha sine beta, and there are, let me break up this wire into two parts. There's a wire 1. I'll break up this. This is wire 1, 2, and 3. And due to 2 and 3, how much B bar at point P? Should be 0, no? Because any reason, the point P lies on the axis of conductor. There's a conductor, and the point P lies on the axis of conductor. Similarly, point P lies on the axis of third conductor. This is like a semi-infinite wire. 3 and 2 are semi-infinite wires. One end is at infinity, other is at finite point. And the point P lies on the axis of a conductor. So what should be the field? Field due to at P, B2 and B3 should be 0. Means due to 2 and 3. Only due to 1, it will be non-zero, and that we are calculating here now. So mu naught. Perpendicular distance, I think the formula according to this is what the perpendicular distance, this A will become equal to D. That A will become equal to D, so write 4 pi A. Come for sine alpha. So how we are measuring sine alpha, sine beta? Sine alpha is 60 degree, no? Plus 60 or minus 60, what we can write it? Plus 60. What about beta? Minus 30. No, not infinity, that one. One end is at 60, other will be at minus 30 degrees. So there should be mu naught I 4 pi root 3 by 2 minus 1 by 2. Okay, just wait. Some direction of current based on that. The direction of current is, I didn't notice. Okay, let me put it again. Look at this one. Which will be alpha now? Alpha will be 60, minus 60. Beta will be plus 30. Any reason for that? Current I is upward. If current I were downward, what I have done earlier, it would have been nice. It would be correct, that one. So it is like here alpha will come. So if you are getting confusion, so you can do like this. If this is the, we take this is alpha, this is beta, no? So beta what happen is plus 30. What about alpha? Alpha is measured opposite to beta. So therefore alpha will be negative now. So this will be sine of minus 60 plus just do be careful related to that. So total will be mu naught I 8 pi a 1 minus root 3. Okay, this should be the answer. Huh? So just be alert. So the field due to 2 and 3 should be 0 because the point P lies on the axis. So that alpha beta, you have to be very careful about in what sense you are measuring.
Sir,
Okay, no, yeah.
sir, in that question, alpha equal to 30 degrees, we have to consider, no, sir, because when we take a rod, the current is flowing I in that direction. Then the upper part is known as alpha, no, sir. The uh, the line connecting that
Okay,
point
okay.
to the upper part, alpha equal to 30 degrees, we have to consider.
Wait. So it is a point there, no? There's a line, no? So the alpha, okay, alpha will be minus 30. Yeah. 30 beta. Okay, upper, this will be upper, we'll do one thing, P1, P2 if I write it. Alpha will become minus 30, yeah. Alpha will be minus 30, beta will be 60. Minus 1 by 2, root 3 by 2. So root 3 minus 1 will come. What about direction? Direction should be out of the plane. Upper end, no? P1, P2. I just made correction, just do notice. Huh? I take the next one here. This is alpha. Still okay. I think you keep one diagram in the end. Beta is what should be 60. No, there's a reference line. Say I'll draw a reference line. There's a reference line. So is what there's a reference line. And any angle below reference line is beta. Any angle above reference line is alpha. So what is alpha now? Alpha is measured below reference line. So alpha should be negative. Okay, this one. You take there's a reference line. Based on that reference line, what happen? You can categorize what is alpha and beta.